And in this demo, we're going to talk about building your first declarative agent for Microsoft 365 Copilot. We're going to kind of a positioning and test out a few things and making sure that everything is working properly with the Copilots, and I'm going to do a few live demos as well. But before we go actually there, I wanted to kind of talk about bit about positioning of all of this. So of course, the Microsoft 365 is the overarching Copilot. Microsoft 365 Copilot is overarching Copilot across all of the different capabilities, and you can actually build extensibility for Microsoft 365 Copilot using multiple different ways. And you can actually surface your extensibility in multiple different locations, in multiple different options within Microsoft 365 as well. Now, when we talk about building agents in Microsoft 365, we do have multiple different options of doing that. We do have the no-code options, which is technically the SharePoint agent options, or using the agent builder. Both of them are kind of a no-code, low-code options to do that. You could argue that, well, it's not code, but then again, you're kind of coding using natural language. So it comes back on what is coding, is giving instructions and examples and things in the natural language. Is it coding or not? Debatable. But Agent Builder and SharePoint Agents are basically the easiest ways to get started. Both of them, SharePoint Agents, we have been covering in community calls. We'll talk about Copilot Studio and Agent Builders in community calls, definitely more in the future. And then today we're going to actually use the Pro Code option of doing that. So I'm going to explain why that matters and why would you do that as part of the demos as well. Because again, the spectrum is broad. You can do all of these things in multiple different ways, but let's talk about today about the Pro Code option. So we're going to use Teams Toolkit in this particular scenario. So we're going to build a declarative agent today. Technically, if we think about Pro Code options of creating Copilot agents, we traditionally divide this in two main sections. Declarative agents, which are grounded based on the information, for example, in the Microsoft 365. You can associate to the SharePoint and OneDrive data. You can associate actions for it. You can actually do integrations of even APIs directly on declarative agents. You can do images, graphics, all of that already in there. But you're kind of using the engine which Microsoft is providing. So declarative agents means that you are defining behavioral things using JSONs and natural language. If you really want to go to the board on, well, I don't like how Copilot is actually doing things. I want to actually own the business logic that I want to choose which LLM large language model I'm using behind the scenes. You can still do that. And that's the custom engine agent flow where you actually then own the whole thing. And that's something where Teams AI SDK, which we went through in some of the community calls on today, definitely comes to as one of the options to take advantage. Now, in this demo, we kind of focus a bit more on declarative agents and what it actually means. But the key point here is to understand that the user experience is Microsoft 365. So we're basically surfacing stuff in Microsoft 365 when we're using declarative agents. We're telling the Microsoft 365 Copilot to behave certain ways. That's really the definition of declarative agents. Orchestrator foundational models are provided by Microsoft 365. You don't actually control them as a developer or as a user who's creating these declarative agents. But what you do control is the instructions and grounding. So you're basically able to define the behavioral instructions. You'll be able to define how would the agent behave, or this instance of an agent will behave. The grounding means that you're able to associate the knowledge and behavior, for example, files within a SharePoint site. So you're able to create a declarative agent and say, hey, here's the SharePoint site where our HR information is being stored. Associate all of your knowledge, not just on the wild internet information, but also on this particular files, which are on this particular document folder. And that will basically do the rack founding or grounding directly on data in there. And then you're able to do actions and capabilities. For example, you're able to associate the declarative agent even to a custom API if needed. You can do graphics, you can do code interpreter. I can't pronounce that term, but anyway, you can do additional things as well for declarative agents, but you don't have a ownership on all of the things. You're basically just adjusting the behavior, how the Microsoft 365 Copilot is behaving. So let's actually have a demo on this one. So let's jump on a demo, spend a few times in Copilot, and we're going to create a custom declarative Copilot in Teams Toolkit as well, so we kind of understand how this works. So let me jump into the Copilot side. First of all, one of the questions might come up on why do I actually need agents? We actually get this question quite often, which is why isn't Copilot already good enough? Why do I need to create specific agents? Well, the specific agents are technically configured for a functionality. So if you think about the Copilot here, let me zoom in one more step forward. I can actually tell this Copilot to start behaving in certain ways. So I could actually do something like the tic-tac-toe was an example of within today's or this week's prompt. So I can pasting the tic-tac-toe prompt in here, which starts actually the Copilot then behave based on the system prompt. Actually, let me go here and let's do this one more time. There we go. I'm basically telling the Copilot that, hey, we kind of work as a tic-tac-toe, and we kind of then the Copilot starts behaving like a game of tic-tac-toe because I'm telling that to do that, and these are the rules, and this is how it should be behaving, who's winning, what does it actually mean, and all of that stuff. So I'm giving a prompt to define its behavior. And now I can actually, for example, say, start playing the game of tic-tac-toe with LLM, and then it starts playing against me. So that's now the latest rendering. Let's put it in 3. So we're kind of playing against the LLMs. And if you think about this from a, let's say, classical development perspective, this is now the key point to understand as we're moving into the age of AI and LLMs. Writing something like this as a chatbot engine before AI and LLMs was an option for us is incredibly hard. So I can actually have a discussions here. I can basically say different ways of me indicating my intent, saying place X on the position, things also position 2. Previously, the logistics of me trying to figure out the user intent based on just a random text, what the user is writing or saying in audio, would have been really, really hard. As we have the LLM and AI helping us to do that, it doesn't really matter if we even do typos here at position on. It's able to actually detect my intent. So it's able to understand that, oh, you actually needed position 6, so therefore I will put it in position 6. Even that kind of a logistics on resolving that typo in the old way of doing things would have been incredibly difficult. So if you've written any code of if then go to in previous years and previous times, you can start trying to figure out on how difficult would it have been actually to resolving that intent directly from that thing and fixing typos. It's just magical what you can do here. By the way, let's actually win the game. So let's put it in 7. Hopefully we can win the game. I think we wanted this to update the port. You should actually understand that I'm winning. That's already 3 in a row. Okay, fine. I'll put it in a 4 still. And I guess it's telling me that I'm winning the game. Now, it actually did realize that I win the game from that line. So that's actually cool. So the LLM actually realized that, yeah, you actually won the game. Thank you for that. Now, again, the implementation, how we program and do things with LLMs and AI and agent is completely different as it was previously. Now, as part of the Copilot camp, there's a great example, an exercise, which is about geolocator game. So this is a geolocator game, which is already deployed in here. It's a great example of a simple agent. In this case, it's a game. And we do understand that obviously agents are much more business power driven, but it actually demonstrates again the power of the agents and LLMs. Geolocator game again is part of the Copilot camp. There's an example how to do this. We're going to walk through the process today as well, just to demonstrate how this can be done really fast in Teams Toolkit. But key point here to understand is that I can actually create the geolocator game also just into Copilot chat. So what I mean with that one is that if I copy the chat and the prompt, which we used for the geolocator game, again, in the same way as we did for the tic-tac-toe, I can tell the Copilot to start behaving a certain way. Like in this case, it's basically now giving me, starting to give me prompts on, hey, let's play a geolocator game. Why? Well, because that was the prompt what I provided in here. Now, why would I actually create this as an agent? Well, because I want to have a dedicated experience. So from an end user perspective, first of all, I can actually give it as an instance, which the user can easily find. It could be learning coach, it could be writing coach. The user doesn't need to copy a system prompt. They don't have to copy any of the behavior and skills or connections or API connections behind of the scenes or the grounding information data. That's actually already there as the configuration for the agent. So rather than asking the end user to copy paste the big prompt and explaining how it will start behaving, let's go to the geolocator game. Let's start actually clicking a button. I can start the game, and the 10 geolocator game actually starts asking questions. Okay, you will give me some clues, and I will need to guess which name it is. This is organic continent Europe, known for its temperate maritime climate. Let's say Amsterdam. And nice try. This is a famous landmark, Eiffel Tower. I think everybody knows where Eiffel Tower is, or most of us know. Never assume that everybody knows that. It is Paris, and yes, we got some points on that one. And now I guessed in 2 clues, and I earned 8 points because the rules which I gave in the system prompt, how it should be behaving, it's calculating the points for me. What's actually kind of interesting here, if I let's play again, and if you actually again start thinking, how would I implement this without LLMs to understand the user behavior, the intent, and let's play again means there's a new game starting. The city is located in Asia, known for a humid subtropical climate. I'm going to guess Bangkok. Just guessing. It's a big city. Nice try. Home of famous landmark, Tokyo Tower, which is inspired by Eiffel Tower. That's a bit giving us away that maybe it's Tokyo. Yes, it's a landmark in Tokyo, but yes, so I got it true. Now I can also do something like what's the point score? And it's giving me then the point score of 16, and you scored 8 points each of the 2 rounds. Now, what's interesting with LLMs and the AI is that I can start debating with it, and I can say, I guess the first question on first try, my point should be then 18. Because it's configured to help me, it's going to actually help me to fix that. So it's going to actually now recalculate. Oh, no. I apologize, my mistake. You are correct. You guessed the first city, Paris, on second try. No, it's not actually answering me the right thing. Now I'm having an interesting debate on on the LLM. It's now contradicting itself. You guessed the first city. Okay, anyway, I'm not going to have a debate with the LLM right now. But anyway, it's an interesting how the LLM and AI can have a discussion. And it's able to understand again the discussion with you. Now, how would we actually build all of this stuff? Super easy, incredibly easy. So let me actually go here and let me start a Visual Studio Code. We do have 6 minutes before we need to close the call. That's more than enough to do even live debugging on all of this stuff. So what we're going to do is build a declarative agent. The cool thing about the Teams Toolkit also is that it actually gives us the option of double check, for example, my environment and double check my Copilot license, all of that stuff. There are a few different options nowadays on the Copilot starting this development that we can actually use the pay on demand option as well. However, that will come pretty expensive pretty fast if you're doing development in Copilot when you start asking questions and playing around with AI. So the option and the license option is definitely the best way to go. Now, let's actually create a declarative agent. Let's actually create a declarative agent. Let me select the declarative agent from the top. Let me move that away. Let me go actually one step back. I'm basically adding a new project, and then I'm saying declarative agent as the option. So I'm able to start from there. There are a few different other options, obviously Teams Toolkit, to get started on building other stuff as well. So let's choose declarative agent option. We're going to say no action in this case because we want to keep it simple, but there are other things which you can include in declarative agents as well. So no action in this case, and let's put it in default folder. It doesn't really matter. Let's give it a name, community call demo declarative agent, DA. Cool. That's creating us the solution. And we're pretty much ready to go to start even testing within our environment. The way this works and why it actually is so incredibly easy is that the Teams Toolkit makes it really, really easy. So first of all, I'm already connected to my development environment, which is in this case is to Contoso Ira on Microsoft.com. So I'm already connected there. The Teams Toolkit remembers that. In my case, I'm not connected in Azure, but this connection gives me already the option to test around with declarative agents. I can start testing things. Now, how would I actually implement the agent? That's pretty easy as well. So if I go here and extend the app package, we can find the manifest, and this is technically the Microsoft Teams schema manifest. You can see it from here. But now, as we build declarative agents, we do have a new option available in here, which is the Copilot agents, which is referring to declarative agents JSON. And that's basically where we are defining our declarative agent. How does it actually work? How does it behave? And all of that stuff. So the details on that one. And in our case, the key point here is that it's actually pointing to the instructions txt. Now, we can actually modify this behavior a bit. And we can actually add the instructions on declarative agents in here if needed. We don't have to, but that's definitely an option. We're not going to do that today because we only have a limited set of time, but I want to actually show how we can get this one moving with the Teams Toolkit, creating a first declarative agent. That was the objective. Now, I will go to the instructions. I will copy these from another file, but the same thing what I copied directly to the Copilot chat to make it work like a game, I'm actually copying that directly to the agent instruction. And if we quickly look on here, we can actually see that it's a game hosting for geolocation game. We give instructions on the points. We also say, you guessed the city, how it should be working. The offer, second clue would be offering a hint about city's landmarks or natural features. That's why it says Tokyo Tower, and it was pretty obvious that the example was Tokyo. Now, that's it. I'm going to save declarative agents. We're not going to do anything in here. This is just a demo, and I will go to the Teams Toolkit, and I will keep provision. And that's when the magic actually happens, how incredibly easy it is to get started. So let me go in here. Let's go output panel. Teams Toolkit actually validates things, make sure that everything is working properly. The files, everything is OK. Behind the scenes, it will give me nice level of instructions and descriptions and error descriptions as needed. Then it will deploy this from behalf of me directly to my tenant, the tenant which I'm already connected, which is the Contoso Iro. So I can actually start doing testing. I can do debugging as well if needed on that side. But if I now go here, and we can actually, you maybe saw it quickly jumped in here live as I switch on the screen. We can actually see the community called demo DA already available. And here's our community DA. And now if I say start that game, I'm actually able to start the game of having the geolocation in place. Now, in our case, we didn't include any starting dialogues or starting prompts like we have done with a official example directly following up on the Copilot camp. But it's actually really, really cool that you're able to start creating this super fast and testing them directly within a Copilot, just with a click of a button. You're able to do debugging, you're able to do things and start playing with the game. Cultural heritage has a maritime, I'm going to say London. Da-da-da. Yes, and that was magical. I got it in the first try. Anyway, super easy to do. And again, there's a lot of different options what we can actually extend here. There's a lot of documentation available, how to do more with declarative agents, what are the options, what are the facts, FAQs, write instructions, efficient instructions is a great guidance as well. So how would you define the behavior directly within the actions? So you're able to define a different behavior than just within the Copilot chat, but in the agent what you are implementing. API blockings available as well, which is an interesting option. And then we do have awesome examples available. Also, even out of the box, Microsoft provided, for example, idea coach or writer coach or career coach options, and these are open source and they're actually available within our within a GitHub. So you can have a look on for example, what are the instructions for that particular file? That's all available in the app package, for example, for that one on instruction txt, and how did that particular agent was actually defined, and what are the behaviors what we provided to make it behave in a certain way. And again, that's basically these things are open source, which are available from the store as well. But that's quick intro on that one. From a time perspective, we didn't want to spend too much time there. We will do more advanced stuff on declarative agents and other agents definitely during the spring 2025. Quick set of resources on the Copilot extensibility. Copilot Camp, definitely #1 resource to get started on things. It was already called out in the community chat, as well as a great resource to get started and understanding the basics on how do we implement all of this stuff. A lot of other options available for you as well. But that's it for this time.